Units and Measurements, Part 2. Now in this video, we will discuss about dimensions. In Part 1, we defined physical quantities and how we can divide it into two categories, that is fundamental quantity and derived quantities. Now fundamental quantities are those which are independent of each other. That means you cannot express these quantities in terms of one another. However, derived quantities are those which can be derived from the fundamental or base quantities. Now, as you can see, there are 7 fundamental quantities and rest of the quantities of our interest can be derived from these base quantities or fundamental quantities. How we can do that? Let us see. If you take the simple example of speed. Now speed can be written as distance upon time. Now distance, which base unit is this? Length. Time can be written as time only. So I can rewrite this as length into time to the power minus 1. Similarly, if I want to express density, density can be written as mass upon volume. Mass is already your base unit, so we need not touch it. We can rewrite it as mass only, but volume can be written as length cube. So this can be expressed as mass into length to the power minus 3. Now you can see here it is really difficult to write the complete. So for convenience, what we can do is that for mass we can use capital M, and for length you can use the alphabet L. For time we can use T. For current we can use the alphabet A. For temperature we can use the alphabet K. For amount of substance you can use mole, and for luminous intensity we can use CT, that is candela. Okay, so I can rewrite your speed as L into T minus 1, and similarly density I can rewrite as ML minus 3. So one thing you can note here, when we are expressing the derived quantity in terms of fundamental quantities, we are mainly expressing them as the product of the base quantities with some power. So dimensions are nothing but these powers, or you can say these exponents. Like in this case, the power of M is 1, L is minus 3. Since time is not there, I can just write it as T to the power 0, because anything to the power 0 is 1. Similarly here M is missing, so I can write it as M to the power 0. So what do we mean by dimensions? Dimensions are these exponents of base quantities which come in the expression of your derived quantity. So when I talk about dimension of density, so density has got a dimension 1 for mass, dimension minus 3 for your length, and dimension 0 for your time. Okay, so let us see now how we can write the dimension of other quantities. Now if you take the example of force. Now force can be written as mass into acceleration. Now mass is already a base quantity, so we can write it like this. Now what about acceleration? Acceleration is your change in velocity upon time. Okay, now here we have to understand what should I write for this change in velocity. Now when I find out change in velocity, if you take a simple example, let us say the velocity has changed from 3 meter per second to 5 meter per second. So I can write it as 5 meter per second minus 3 meter per second. So what will be the answer? The answer will be 2 meter per second. So when I am finding change in velocity, I am getting the velocity only. So I can write change in velocity as velocity for dimensions. Okay, velocity upon time. And velocity we have already calculated here. What is velocity? Speed and velocity will have same dimension. Okay, because velocity is displacement upon time. So that is length upon time only. So I can write here, this is m, this is LT minus 1 upon T. So MLT minus 2. Now here we have to note one more important thing. We always put a square bracket. Now why do we put a square bracket here? What is the purpose of square bracket? Square bracket indicates that when I am writing force is this, I am basically writing the dimensions of force. This is not the magnitude of force. So similarly, you can find out dimensions of other quantities like momentum if you want to find out. Momentum. So momentum can be written as mass into velocity. So this is m into LT minus 1 mLT minus 1. So dimensions, what are the dimensions of momentum? Dimensions of momentum is 1, 1 and minus 1. For mass it is 1, for length it is 1 and for time it is minus. Now here we have to understand three important things. Number 1, when I express any quantity q as m to the power a, l to the power b and t to the power c, then a, b, c are known as the dimensions of the physical quantity q. Number 2, m to the power a, l to the power b and t to the power c with square bracket is referred to as the dimensional formula of q. And number 3, when I express this q as m to the power a, l to the power b and t to the power c, then this is known as dimensional equation. This is not a normal equation, it's a dimensional equation.